All right, my mind's going a million miles a minute on this idea of pumps and pipes, and you're seeing it right there live on the medical side. You see the aerospace elements, and now we get a hometown hero to come up to the stage. He has been a part of the Houston Startup Showcase here at the Ion. We celebrated his most recent round of funding up at the second draft bar, which we'll be at later on today, at an event we call Raise a Glass to Another Round. Guys, this is very exciting to see the journey this startup has been from founding all the way up to today, which is commercialization. Let's give a big round of applause to Mike Francis, CEO and co-founder of Nanotech.
I think my profile picture is a couple months out of date. What do you think? I don't know who put that up there. Whenever I get the opportunity to do things like this, I always want to take a step back and thank some people. So Jan and Joey and the team of the Ion, they've given us tailwinds every step of the way. And that's what startups need. They need tailwinds. And places like the Ion, Greentown Labs, Rice University, events like this, people like yourself are what is going to make Houston a top 5 startup city before the decade's over. So my name is Mike Francis. I'm the co-founder and CEO of Nanotech, and we're a true garage startup. So we started out of a garage here in Houston. What we produce is a particle. So the particle looks like a white powder that can be added into different building materials. And so you can picture a situation where there's white powder going everywhere. You know, we're in our jumpsuits, our white jumpsuits. We're, making our product out of my old beer tanks. And, it was very much a startup situation that looked like, very much like a Breaking Bad situation. We got picked up by Halliburton Labs. So we were Halliburton Labs' first clean energy startup. And so I guess we tricked them into accepting us into their system. We were part of Rice Alliance Clean Energy Accelerator. And all of our first customers were Houston customers. And so that's why I really, really believe that Houston is going to be a top. Our last round of funding, we actually had an entire Houston and Texas round of funding. So everybody that invested in us were corporates or venture capital based in Texas or based in Houston. So it can be done. Ooh, I'm gonna get to that one here in a second. So starting with our vision. So what do? So at Nanotech, we keep heat out, we conserve heat, and we make things more energy efficient. So we've developed an insulative ceramic particle which can be incorporated into many building materials to keep heat out or keep heat in at different levels of the energy spectrum. So the particle that we actually sell is a 4-micron particle that has nano components attached to it that allow it to deal with the different wavelengths of the infrared spectrum. So at ambient, we're in the built environment where we have different products that improve energy efficiency. So 40% of all US CO2 emissions comes from the demand for heating and cooling of buildings, and 48% of that comes from HVAC use. You'll see here in a second how we can dramatically drop that through very, very simple technologies and very simple infrastructures that already exist. The second problem that we're solving is a big one. We are trying our best to solve the wildfire problem in wildfire-prone states. As about 2 months ago, I've been working on this account for almost 2 years. We got our first project with the government of California, doing the fireproofing for them. And we're working on becoming the sole source provider of our solution. So what is it that we have? So we have an insulative ceramic particle that has about 8 different components attached to it that can be incorporated into lots of other materials. So paints, polymers, acrylics, vinyl esters, polyesters, silicones, cement, concrete. Once it's incorporated into those matrices, it will stop the heat from transferring through. So we also commercialize our own coatings and our own products that are activated with our particle oxide. So our first product is a fireproofer. It will fireproof to about 1,800 degrees Celsius or 3,300 degrees Fahrenheit. There's no chemical reaction. So there's no chemical reaction that happens, which means there's no smoke, there's no flame spread. It stops the heat from going through. Our beachhead market is actually a cool roof coating. So if you ask anybody in our organization what we do, we're roofers. We're laser focused on owning the roofing market, and I'll talk about it here in a second, and then starting with the roof and then eventually going after all the different components of the built environment. We have a perfect insulator, and then we have a really cool one coming out, which is a clear coat. So the clear coat has our insulative particle inside this clear resin. It lets light through, but keeps heat out. And it allows us to go on windows, solar panels, skylights, etc. When we're on a solar panel, it actually improves the efficiency of the solar panel between 15 and 20%. So we'll be launching that here next year. So let me show you what it does and how it works. So I like to do these videos in the backyard with my kids. So I have 3 kids at home. So we do Science Sundays where we try to burn stuff in our backyard. Most of the time it doesn't burn, but we have had the fire department called on us by our neighbors. But I really like doing that because 1, it gets my kids involved in the science of what we do. And then 2, it's just a really fun activity for our kids to do in the backyard. So we don't shoot very professional videos, but we have a lot of fun doing it. So how does it work? So this is our fireproof coating. We have our insulative ceramic particle embedded and loaded into this acrylic emulsion. We use an acrylic emulsion because there's no reportable VOCs, volatile organic compounds, which allows us to go in places like California. The way that it works is pretty special. So it has what's called a perfect emissivity. So emissivity is just on a scale of 0 to 100 or 0 to 1. And a perfect emissivity means that it acts like a black body. So our coating has a perfect emissivity, so it's absorbing and emitting the heat away. And then we combine that with a low thermal conductivity. So thermal conductivity is just the resistance of heat through the thickness of whatever it's embedded into. Our particle itself, for those that are in this space, has a thermal conductivity value of 0.012 watts per meter Kelvin. What that means is it's lower than aerogels, it's lower than air, it's lower than many of the ceramic tiles that are out there that are used by NASA and others. So those 2 properties allow us to dissipate the heat away, and we can do it at a very minimal thickness. So most of our fireproofing is done between 3 and 5 millimeters, where our competition many times needs to use inches and inches and inches. The other really big fact is it doesn't produce smoke, there's no flame spread, and it stops the heat from going through. That means it can be used on the inside of structures as well, because smoke inhalation is a really big deal. Because there's no chemical reaction, what happens is our particle comes together, there's a sintering effect that happens, and it forms a physical shield, and that is what's left once the resin burns off. So if you saw the last video that I showed you, you saw how the resin burned off. So the resin will burn off at about 300 degrees Fahrenheit, and then what's left is a 100% inorganic shield that has sintered in place that will continue to protect the substrate as long as it stays below 1,800 degrees Celsius. So most wildfires will burn at around 1,200 degrees Celsius. So this allows us to continue to protect, not only give time, but to protect the structure as long as it stays below that temperature threshold. This is a very meaningful thing to me. So this is my 4th startup that I've done. And I'm really, really excited to be here because we have lots and lots of challenges and we need help. I feel like I'm a steward of this technology and it's my job just to not screw it up. And so I'm really excited to be here because now we have an extended ecosystem that can help us, help this Houston startup, this Houston garage startup, get this technology to the world. So our beachhead market is in the built environment. This is our roof coating. So our roof coating, it's about 95 degrees outside in Houston. So you can see our roof coating is at ambient, and then it goes from ambient 95 degrees to about 167 degrees. What's really cool about this, no pun intended, that was the first time I used that joke. It worked. I'm going to use that again. What's really cool about this is most roof coatings deal with reflectivity. So reflectivity is just a reflective surface. In most cases, it's a white surface for roof coatings. Reflectivity means the heat hits the roof and then bounces back up into the atmosphere. What's the problem with it being white? Roofs tend to get dirty. And so what happens is once the roof is dirty, then the performance degrades substantially. So most roofing products use what's called solar reflective index, or SRI. It's an equation of emissivity and reflectivity. Our challenge is that we have added a third dimension. And that third dimension is the low thermal conductivity, or the heat resistance. So at a very basic level, our roof coating is targeted towards the remediation market. So we don't go on new roofs, and the reason is because then the warranty is void. We go on roofs that need to be remediated instead of replaced. So we are about 75% less than a replacement cost, and you get a completely new roof coating, new roof, and a new 10-year warranty on top of it. And so one of our challenges that we faced is it's not just a cool roof. It is an impenetrable barrier that has to stop leaks. It has to deal with wind. It has to deal with the elements. And so we invested a lot of money and a lot of time. And as of about a month ago, we're certified in Miami-Dade, which is the hardest market to get certified in, as a roof coating that can now be used across all 50 states. So at a very basic level, instead of replacing your roof, you remediate it. And because of the energy savings, there is a huge sustainability play. So this is a large retailer, not to be named, but the before temperature on the inside, so this is up pointing at the ceiling, is 111 degrees. So that is through the insulation, that is literally just pointing up. After our coating, it goes from 111 degrees to 76 degrees. So this particular facility ran their AC at around 74 degrees. So instead of having to drop it from 111 to 74, it now drops it from 76 to 74. We were on this roof for about 6 months. We're still on this roof. We haven't gone anywhere. We were on this roof for 6 months while they collected the data. We got the data about a month ago. For this particular facility, we dropped their HVAC consumption over the summer by about 49%. Not by about, by 49%. What that means is pretty significant. One, they saved from a sustainability play. Instead of replacing their roof, they coated on top, saved about 75% of their costs. This particular facility, their payback period is right over a year. So instead of having to replace the roof, they now have a coat on top. Because of the energy savings and because of our price point, this particular roof paid back in a year. So facilities managers are happy. They punted the cost of CapEx down the road. The energy people, the CFOs are happy because we save them 49% on their utility bill. And then the sustainability people are also happy because we're dropping HVAC consumption, which drastically reduces CO2 emissions. It's a huge contributor. So why isn't this everywhere? Well, this is a horrible slide, but I'm going to talk you through it. So SRI is the primary measurement. So solar reflective index. Solar reflective index is the primary measurement of emissivity and reflectivity. Our challenge is that third dimension that we're now introducing in the market. So when you measure us on SRI is a score from 0 to 100. We're above 100, so we perform well, but the current measurements don't take into account our third dimension, which is the resistance of heat. So where we need help, and I know that there's a lot of experts in here, so this is a true cry for help, is we need to figure out the energy balance, sell that energy balance into the governing bodies so that those scores that are typically used for things like tax credits, things like energy efficiency improvements, and so that people can measure it, has to include that third dimension. Our challenge is our particle is temperature dependent. So as the temperature increases, our thermal conductivity actually drops. So depending on how hot it is, whether it's 1800 degrees Celsius or if it's at ambient, you're going to get different temperature ranges and improvements across the spectrum. And so we need help pulling out each of the pieces of reflectivity, emissivity, and low thermal conductivity to build an energy equation that can then be accepted and adopted into the market. And it's a huge challenge, but I can think of no better room to help me solve that challenge than the ones that are in here. At a super high level, that's what we do. I'll close again just by saying thank you. You know, every startup looks for a tailwind. I think I've been on this stage probably at least 20 times now, and every single time I am so unbelievably grateful because 100% of the time after I do something like this, I get another tailwind and another tailwind. People in Houston were built different. We help each other. Startups help each other. And Houstonians are the best at helping each other. So as all these other companies are presenting, know that you're not just helping a company succeed, you're helping me, my family, my employees' family, believe in a dream, risk a lot to make it happen, and entrepreneurship is a team sport, and you guys are definitely part of that team now. So thank you.